Alright, we are back at it again with another problem. Another problem. We have a problem about fluid mechanics regarding buoyancy and flotation once again. So, basahin na natin. A container holds two layers of different fluids. One fluid having a specific gravity of 1.2 is 200 millimeters deep. And the other fluid having a specific gravity of 1.5 is 250 millimeters deep. A solid spherical metal have a diameter of 225 millimeters, or simply 0.225 meters, and a specific gravity of 7.4 is submerged, such that the half of the sphere is in the top layer sa fluid 1 and the other half is in the bottom layer of the fluids. Compute the weight of the metal. Next is compute the buoyant force acting on the object. And C, compute the tension in the wire. So, meron tayong tension dito sa wire, holding the sphere to maintain its position. Okay. So, unahin natin yung letter A. Let's compute for the weight of the metal. We know that the formula for the weight of the metal, spherical metal in this case, is, di ba, ang formula is gamma of our object times the volume. So, selpak lang tayo. Given naman yung SG of our metal, the SG of metal is equal to 7.4. 7.4 daw yung specific gravity ng object natin. So, 7.4 times gamma of water. The gamma of water, 9.81 kilonewtons per cubic meter. And then, the volume. Anong volume ng sphere? Now that we have here a sphere, the volume of a sphere is, we all know, is 4/3 pi r cube. Given naman yung diameter, so divide mo lang siya ng 2, so that will be equal to 0.225 divide 2 is 0.1125 meters. So that's our radius. That should be cube para maging unit of volume. Tama ba? Alright, so plugging that into your calculator, you'll arrive with the value of weight in kilonewtons, kasi cancel yung cubic meters, 0.43295. 43295 kilonewtons. Yeah, that's the weight. Or simply, gawin na natin, pwede bang 433 newtons na lang? Yeah, pwedeng ito na lang. 433 newtons. Simply multiply it by 1,000 para maging newtons. So that is for letter A. And then we are asked to find the compute the buoyant force acting on the object. Since meron tayong dalawang fluid, yung bawat fluid na yan ay mag-exert ng buoyant force sa object natin. Tama ba? Are we clear? Shishal. So, magkakaroon ng buoyant force yung fluid 2. Mag-exert yan ng buoyant force. Kung may drawing ko lang, yan, buoyant force. Tapos ito rin, buoyant force 1. Tapos ang object natin, may weight yan, di ba? Weight of our object. Yeah. Alright. So, kung mapapansin nyo, di ba meron tayong tension dito. May wire pa lang nakakabit sa spherical metal natin. Tingnan nyo yung specific gravity. Sobrang laki niya compared sa fluid. So, ang tendency niyan, mas dense siya sa dalawang fluids, lulubog yan. So, ang mangyayari sa tension natin dito is paparito. Kasi it's tension naman, laging pahila. Yeah. So, lagyan na lang natin dyan for future use. Kasi pinapahanap din yan sa atin. So, ngayon, let's compute the buoyant force. Buoyant force 1 muna. Di ba alam na? The buoyant force acting on the object is simply equal to the buoyant force exerted by fluid 1 plus the buoyant force exerted by fluid 2. And note that the spherical metal natin dito, half of the sphere is nasa fluid 1 and half of the sphere is in fluid 2. So, anong gusto nyo? Diretso natin? Or kunin natin separately? Sige, separately na lang para ano. The buoyant force muna for the first fluid. That is the formula for buoyant force. Lagay na lang natin dito. The formula for buoyant force is yung gamma times the volume displaced. Gamma ng fluid. So, given naman yung ating specific gravity, so salpak tayo dito sa problem na to. So, times 9.81, the gamma of water, that is kilonewtons per cubic meter, times the volume displaced. Ang mangyayari dito, yung volume natin to, di-divide lang natin sa 2. Kasi, kalahati ay nasa fluid na yun. So, let's do that. 4 over 3 pi 0.1125 meters cube tapos divide 2. Yeah. So, pressing that into your calculator, you'll get the buoyant force exerted by fluid 1, which is approximately 0.035 kilonewtons. And para sa buoyant force 2 natin, it's just the same formula, same process. Di-divide mo lang ulit yung volume ng 2 kasi the other half is in fluid 2. So, copy na lang natin. So, palitan na lang natin ang mga values and subscript para mas madali. So, this is the buoyant force exerted by fluid 2 and the specific gravity of fluid 2 is 1.5. And pressing that into your calculator, 0.044 kilonewtons. So, these are the buoyant force exerted by fluid 1 and fluid 2. So, to get the total buoyant force experienced by the object, we simply add them together. 0.035 kilonewtons plus 0.044 kilonewtons. Add mo lang yan. That is equal to 0.079. 79 kilonewtons. Or simply, the buoyant force is equal to 79 newtons. Yan. Medyo basic lang tong problem na to. Ang konting twist lang dito is pinaalala lang sa'yo yung volume ng sphere. Kasi kung hindi mo alam yun, eh, wala. You won't be able to solve this problem properly, alright? And finally, we are asked to compute the tension in the wire holding the sphere para ma-maintain yung position niya. So from here, summation of forces lang tayo, Ti pataas and as well as the buoyant force, pwede nating pag-isahin na, and the weight. So ang lalabas diyang equation, taking the summation of forces vertical, we have here lahat ng pataas. So the tension plus the buoyant force sa kabilang side lahat ng pababa, which is yung weight. And to get the tension, we simply subtract the weight with our buoyant force. Ang weight nating nakuha kanina is ito, 433 newtons na lang gamitin natin. 433 newtons minus 79 newtons, that is equal to 354 newtons. So, medyo chill lang yung problem na to. Pinaalala lang talaga yung volume ng sphere. Alright? So, that is all for this easy yet okay. Very nice na problem. Yeah. Alright. 433 newtons yung weight. Buoyant force is 79 newtons and yung tension sa spring is 354 newtons. So, that is all for this problem. Alright.